recognition, some problems in robotics, and especially when you have lots of robots and you're trying to coordinate them. Um, uh,
Yeah.
Structured classification, which is sort of a general capability that underlies a lot of different human type things, automated reasoning and theorem proving. So there's a whole whack of these things that you can map to our hardware, and that's where I'm really have an intense interest right now, and how this might relate to your um, the whole business of longevity is that,
Sure.
I've always thought that fixing the human body is kind of a waste of time, because there's so many things that can go wrong that you'll fix 50, but then another 50 are going to show up, and then
Yeah.
you fix those and then 100 show up. So my view of all that is that if you really want to have really long life, the way to do it is to figure out how to make a copy of yourself in something else. And in order to do that, at a very minimum, you need to have that something else be able to do the things that you are used to doing. So, for example, if I was in a machine that was unable to see an object in an image, it's very unlikely that that thing would be me. Because part of being me is being able to detect, oh, there's a cat. And if
Sure.
I can't do that, I'm not me anymore. So there's a very sort of functional argument that if you want computers to be able to store you, you have to give them the capabilities that make you who you are. And so that's the angle that I've been taking with some of our research
Mm-hmm.
recently, is to try to build more human um, uh, programs that are able to, use information and process it and understand it
Understand.
somehow
Okay.
using the quantum
From
chip.
a high level perspective as well, would you agree that using a quantum computer to say duplicate your personhood or your mind would work better than a classical computer because the quantum computer is operating with the same structure, the same physics that your mind is working with?
No, actually, I think
Or
it's
do
a
you think?
lot more interesting than that. See,
Oh,
what I think is that, and this is by no means for sure, but
okay. Just
I think
theoretical
that,
here. Just very
yeah. So
theoretical.
this is total speculation, but I think that biology is constrained because biological things need water, and they need a fairly high temperature to make all of the things that we associate with life happen.
Yes.
And those things tend to drive you into very classical regions. So I think that all biological entities have entirely classical brains.
Oh,
And so why I think that this is so interesting is that our classical brains, so if you agree with that, then evolution by itself cannot create biological quantum computers, because our brains don't operate in a regime where you can use quantum mechanics to compute. And I don't
okay.
think any evolved creature can. But what you can do is use your brain to build machines that can do that. So I see this as kind of a very interesting potential, a cusp in the development of intelligence, where you reach the end of where biology can take you,
And
or as far as
classical,
yeah,
yeah,
yeah. And then you build machines that can do things that are fundamentally impossible for any biological brain. So
right.
you've created a new type of intelligence that has a capability that you cannot duplicate biologically. And so you let your mind wander about what that really means. You've created an entity that somehow can do things that you can't, not even in
Sure.
principle.
And not even yeah,
So
exactly. Yeah.
it's a kind of a neat concept to play around with in your mind. And but when you reduce it down to practice, for me, in the short term, this is really about being able to build tools, that allow people to do things that they
In the
really want to
short term.
do, like looking for objects and images is something that has a very deep philosophical attachment to it, but it's also a very practical problem people care about when they do searches.
They do. Yeah.
So
The one thing
people are
in
willing to pay for it.
the one thing in aging research I was thinking that I believe was mentioned a couple of times in here and there on the internet was protein simulation and protein folding. Is that a
Yeah.
problem that has been considered for an adiabatic quantum computer such as yours?
Yes, yeah, we've been working with some scientists at Harvard, and we published a paper about 6 months ago that showed how you would map a particular type of lattice protein folding problem onto the machine.
Ah,
How you do more modern protein folds is a little bit more difficult to see, but it's certainly
it
possible. I
is
mean,
possible.
yeah, all our machine is really an engine for doing optimization. So if you have a problem that's at heart an optimization problem, there's usually a way to map it on our systems.
Okay. And I just want to, before we move on to anything else or start to close up our interview here tonight, I did get another question from the audience, and they wanted to know how do you cool your computer to 10 millikelvin? What process do you use? I mean, we're talking about liquid helium. Now, is liquid helium already at that temperature, and you just bathe that copper block in the
No.
liquid? No. That's what I thought.
It's
Liquid
actually
helium's not that cold, right?
It's not.
Okay.
I'm going to give you the short answer.
Okay,
There's two
short
kinds
answer.
of
That's
helium.
fine.
Two kinds of helium. There's helium-4 and helium-3. Helium-4 boils at about 4.2 degrees, and helium-3 boils at about 300 millikelvin. Now, both of those are higher than the operating temperature, so how do you get to that? It turns out that if you dilute one type in the other, there's a trick you can use to pump on the mixture and make it cool to below where either of them boils. So this is called the machine is called a dilution refrigerator, and what you're doing is diluting one type of helium with the other one. And then when you pump it, you put it under pressure. When you pull off the molecules, it turns out that the mixture cools down to something below the boiling point of either, and you can get it down to about 4 millikelvin with state-of-the-art dilution refrigerators.
Okay.
So it's liquid helium, but it's a very sophisticated and clever technique for getting down below the boiling point of either isotope.
All right, and just I want to remind everyone that's viewing tonight, that's tuning into the program, that if you have any final questions here for Dr. Geordie Rose of D-Wave Systems, please go ahead and ask. One other thing, I just wanted to talk a little bit more, instead of the science, just more on the practical aspects of health and longevity. I see that you enjoy wrestling quite a bit, and that that you actually have defeated some of the world's top Greco-Roman wrestlers in the past. Is that true?
Yeah, I used to be a fairly good wrestler.
Okay.
Back in the day. I don't so much do that stuff anymore, although I do still do it as a
recreation,
as a hobby. Although
Okay.
it's not, I don't do the wrestling anymore because that's too hard on your body. But I do some other things like judo and boxing.
So are you? I mean, you do things in your own life as far as diet, exercise, things to keep healthy for the time being.
Oh yeah, absolutely.
Yeah?
I try to, but it's always it's a struggle to maintain the shape that you were in when you were younger, and when you're in really good shape when you were younger, it's harder to become older and have it hard to be. I've been trying to get back in shape, and I used to be a pretty good runner, and now it's just a struggle. As soon as I leave the door, my legs start to ache, and
Sure. I suppose. I mean, starting a company such a revolutionary thing here as far as quantum computing and a startup. I mean, I imagine that takes a lot of your time. It's not.
Yeah, not so much now as it used to.
Okay.
The company has grown significantly, and it used to be that I was very centrally important
and
to
hands-on to everything. Pretty much.
But now that's not true anymore.
Okay.
We've got an absolutely phenomenal team, and the company would do just fine even if I wasn't there now, which was my objective from the beginning.
Okay.
Was to bring in such good people that I'd hire myself out of a job. So that hasn't quite happened yet, but
Okay.
the people we've got are great, and they carry most of the burden now.
Okay. Yeah, and the one short, I just had another point that popped into my head here. In the short term, what you're planning on doing is renting time on, like, say you get a 1,000-qubit computer that offers the competitive advantage over, say, a mid-range classical supercomputer. Then you plan on renting time on that machine, correct? You're not going to.
It'll be up to the user.
Oh, okay.
A lot of users in the short term, especially the ones who want to use the machines to investigate what they can do, like build applications and play with them and sort of use them in the course of research.
Mm-hmm.
We'll want the machines in house, and that's totally fine with us. So the online model was more for the ease of adoption.
Okay.
But a lot of users want to actually have machines in house,
and you will be able to build them and transport them and set these up at different parts of the world where people want them.
Yeah,
Okay.
I mean there are issues as to export restrictions on restricted technologies.
Oh, Yeah.
But pretty much anywhere where that we've seen